really important thing to note again is this problem with our perception of pitch being logarithmic and FT, the bins of the FFT being linearly spaced. So you have to account for that when if you're doing the raw web audio calculations. But these environments that we're looking at today, they take care of that for us so that we don't even have to think about that, which is nice. That's why we have the band, so we don't have to worry about that. And Hydra, we'll see, does something very similar, and so does Marching.js. So I wanted to at least show a couple of examples of visual music that I think are kind of amazing. So this first one I'm going to show is by Evelyn Lambert and Norman Mclaren. It's called Beyond Dull Care. And I think it's interesting because it kind of gives some different approaches to this problem of synchronization, or how do you match visuals with audio. So in this case, they're just doing the visuals for the piece. The audio is the Oscar Peterson trio. And yeah, this is first we get to learn about these knives.
Quality knives.
Probably gonna get to learn about something else. It's better than the Vimeo ads that we saw though. Okay. I'm gonna skip the very beginning of this where it's the introduction. And we'll watch maybe 4 or 5 minutes of this. This is all done by painting and etching directly onto film. So these are etchings right here.
Am I wrong, or you can actually see the audio signal in the when you have it's Super 8 or
Yeah, you have an optical soundtrack, and we'll see something about that.
So that way it's easy to follow, no?
It helps for sure, yeah.
Can you generate audio out of video instead of the other way around?
So the next example we'll look at will do that. Yeah. Those are basically those sine waves we were just doing. Yes, sort of. So actually the next section is really beautiful as well, but I'll let people watch more of the links in there. I'll let people watch more of it on their own. But I think this is kind of cool because you see examples of this really tightly coupled synchronization between the audio videos and audio and the visuals, and then you see examples where it's more like an impressionistic type of thing, and it kind of goes back and forth between the like pure responsive visuals to having like a more floaty type of feel over the top of it.
So this painting was done on top of the music, or it was just done after, or?
1949, right?
Yeah, I don't know when the Oscars, I don't know when, 1949, I don't know when the actual music was recorded, but yeah.
Cool.
So this is, the next one is exactly what you were just saying. It's the same idea, but it's somewhat flipped. So in the next example, Norman Mclaren is going to paint onto the film, but he's also going to paint onto the optical soundtrack of the film. So you have a completely blank film strip. He's going to paint onto both the visual part and on the audio part. And I don't know, this kind of blew me away the first time I saw it, because I feel like it's really an example of electronic music from the, I think it's late 30s if I remember correctly, 1940. And it has this sound of like this synthesized electronic music to it.
How do you even write in the like if you just like put something, it makes a sound if you write in the audio part? Because I've seen this video, but like how?
Yeah, and if you look, somewhere I have a link to an interview with him where he actually shows the process of doing this. He's literally just drawing onto the optical soundtrack of the film to create these sounds. So I've mentioned this term visual music a couple of times. I don't think I actually explained it, but it comes out of kind of the history of abstract animation. And in the early part of the 20th century, let's say the late part of the 19th century, in the music field, we have this kind of impressionistic things that are happening, Debussy, Ravel, everything else. In the 20th century, visual artists are getting more interested in the abstract nature of music, where as visual arts had traditionally been representational, we have music which is kind of expressing these really abstract concepts and doesn't have as much of a representational aspect to it. And so this kind of field of visual music started by artists who were sort of trying to break away from representation and exploring concepts found in music like rhythm and more formal orders. So think of Kandinsky or various Bauhaus artists. And then it kind of gradually extended into other composers and filmmakers who were interested in both, or not just working only in the visual domain, but in combining visual and sound together. And so there's lots of really amazing artists. If you just search for the term visual music, people like like Oscar Fischinger, maybe some of you have heard of, or Norman Mclaren. You could watch all of his films. They're all completely incredible. Mary Ellen Butte, the Whitney brothers in the 50s and 60s and 70s did amazing pieces of like going out into the desert for 7 years and coming back with like a 10-minute film with like these incredibly pointillistic, like insane things to imagine creating. Even with they actually made their own machines they used to help them do these films before digital computers, but they're still totally crazy. So if you just search for visual and music and history, and maybe I can put some links in. I didn't put any in there outside of the videos that we're going to look at today, but I can put some links to some more general resources about it as well. Okay, so next up is Hydra. So there's the link in the website, and so Hydra is created by Olivia Jack. It's a really amazing tool that's using this kind of metaphor of analog video synthesizers to create experimental visuals. And basically, when you load it, it'll bring up some default sketch for you to start off with.
Should we run it in Chrome or Safari?
You can run it in whatever, it doesn't. So you won't get.
Yep.
Yeah, I think everything will work. Maybe the audio won't work in Safari. So you might want to run it in Chrome if you want to have the audio responsiveness working. So to experiment with things, you just kind of go here and highlight different numbers. You hit Control and Shift and Return, and it'll change the value and re-execute the code. And what this is doing behind the scenes is it's creating a giant shader, like we just looked at, but much longer than the shaders that we looked at, which were just like 15 to 20 lines of code. These are huge shaders that have a lot more complexity to them in some cases, and it depends a little bit on what your higher level description actually is.
I don't understand when you say huge shader. What would be
I mean,
shader?
a huge shader might be like 50 kilobytes to 100 kilobytes. Yeah, that's what I meant. It's the byte memory hard disk space size. One really cool thing about Hydra is you can just click on this button up here and it'll show you lots of different interesting examples that people have made to kind of get an idea of the types of things that it's capable of, and then you can just start playing around, changing the values and seeing that it did not just do that, you liar. Seeing what happens. There's lots of fun examples just to kind of play around with just by flipping through these. There's also a really nice Twitter channel that's just devoted to people who publish their Hydra patterns, which you can do with this button right here. So that basically tweets your Hydra pattern to this Hydra patterns Twitter channel for the world to bask in or mock, although I don't think I've seen that happen yet. So let's just get started with this and kind of learn a little bit how it works, and then we'll look at how you can bring the FFT analysis into this. It uses a library called meta.js to do the audio analysis and the FFT work underneath the hood. But basically, in the shader example, we started by creating some simple oscillators. In Hydra, you can do that just using the OSC command. That's just for oscillator. It's not like open sound control. And then once you have a graph of some type, a visual graph that you created, you just send it to the output of the screen by typing .out and then an open and close parenthesis. And then again, Control and Shift and Enter will execute the code that you currently have on the screen. So this should look somewhat similar to things that we did inside the shader earlier, but we don't have to actually worry about the signs and all the math to get that. It just kind of does it for us. where are the parameters? I think this is the frequency parameters first. So the number of stripes that you get up on the screen. The next parameter is the horizontal scan, so how fast it's moving across the screen here. So if I stop it, or I move it really fast. And the last parameter is the color palette that gets used. So I don't remember how exactly it determines how that transfers into the colors, but you can give it different values and it'll spit out a different range of colors over the cycle, the various cycles of the oscillation that appear right here.
Yeah, it's really cool.
Yeah. So fun to start playing around with, and then you can just start kind of chaining different things to this. And I don't remember exactly what I put next in the gist, but another fun thing we can do is we can rotate this. So it's measured in radians. So if we do a quarter way around the circle, we get it going vertically instead of horizontally, and if I do some other thing, then we can get diagonal lines. We can pixelate this. So I'll make it a grid of 20 by 20.
One L too many.
Thank you.
Wait. Master P.
This is cool.
Yeah, it's really, really cool.
This is colorable function. That's another.
Yeah, so inside of the GIFs, there's a link to the references for all the different functions that are inside of there. There's also a link to a repo of different examples that you can look at that are a little bit more complex.
Is it possible to map the values to MIDI input?
I believe so. I have not done it, but I think there is MIDI input. I can't say for sure.
I think there is.
Yeah. I know there's open sound control. There's like a little server, socket server that you can use to route open sound control messages in, and I think there's MIDI support also, but I'm not positive about that. One of the other really cool things about Hydra is that for any one of these different numbers that I've got here, you can just substitute a function for it instead, and that function will then be evaluated on each frame of video to determine the actual number that you want to use there. So we could say something really, let's make a variable, I'm going to call my variable phase, I'll set it equal to 0, and let's do phase plus right here. This is going to be weird, but I'll just do it anyways. Because it's measured in radians and not degrees, it's rotating insanely fast right there. But if I wanted to do this, make it a little bit better, I could say return like a phase. All right, I can't make this a one-liner. It offends my aesthetic sensibilities. We're gonna break this up into multiple lines. O1, return phase, there's better. So again, I took that rotate function, and before I had math.pi divided by 3 right here, and now I'm just substituting a function. That function is getting evaluated once per frame to create the rotation value for what we're seeing right there. And we could do the same type of thing with pixelate, either of the numbers, any type of numeric value you can substitute a function in. And that's actually how we're going to wind up getting our FFT data into Hydra, is by having functions that will read the results of the FFT analysis and then apply them to a different parameter of the functions that we're looking at right here.
Phase is like a random variable, or?
Phases, yeah, I just made, you know, larg. Same thing.
Understood.
And I think there's like I noticed earlier when I was playing with it, there's like a built-in time variable. I kept getting confused because I kept calling things time, and there's a time thing that Hydra uses that was like overriding the variables I was making, and so yeah, maybe prefacing your variable names with underscores or whatever. Everything in Hydra is in the global namespace, so everything's on the window object, which makes it really easy to start typing things and experimenting with it, but also really easy to get namespace collisions with potentially. So, I can't remember if the audio works in Safari or not. I'm going to go into Firefox. Well, we can already see in this example, I thought there's some type of audio thing that's kind of working. Yeah. Okay, so what did I have in the gist for this example? No. Keep closing that page. Leave it open. Okay, so yeah, I'm just going to copy this example, we'll take a look at that, and this will bring the FFT information in there.
And then the one you had before. The one you had before had a semicolon. You don't put semicolons.
I am semicolon allergic when I program JavaScript, but they don't hurt anything.
But like the function that was inside of rotate, does that need a semicolon to separate the or it's just like
So this is like a special type of JavaScript function called an arrow function, and it's a little bit weird in how it works if you haven't used them before. But so you can have, if you have a single expression that gets calculated inside the arrow function, then that function gets returned, or sorry, that value gets returned automatically by it. And so you don't need to have curly brackets, you don't need to have a return statement or anything. As soon as you have multiple lines, then you have to explicitly return a value from it. But if it's a single line function, then you can just, you can have things like this, and that'll be the output of the function.
Where is the variable A? Where is that getting assigned?
A is one of these global variables that I talked about. So A represents the audio object inside of Hydra. And yeah, so I'm calling A.show up here. That's giving me, it's a little hard to see, but in the bottom right hand corner, that's the FFT data that I'm getting. And by default, or it's not by default, so down here, I'm specifying the number of bins that I want the FFT to have in it. And the terminology here is maybe a little bit confusing. I think bands probably would have been better, but this is basically doing the same thing that we saw when we were using the force, where we have this FFT signal that's giving me the magnitudes of all these different sine waves that are used to create this more complex signal, and then we're just averaging them to create some type of approximation for low, mids, high frequency bands. So here we're just getting 2 frequency bands, but if I change this to be 4 or 8 or whatever, so now you can see there's 4 different bands in the bottom corner that I can access instead of the one single band that was being used earlier. So once I have those 4 bins, then you can just say A FFT 0, 1, 2, 3 to access any particular one, or you can sum all those bins together, or do whatever other types of manipulations you might want to do. One of the really nice things that Meta gives you, again, Meta is the music information retrieval library that Hydra is using underneath the hood to do the FFTs, is this set smooth thing right here, where it basically allows you to apply a low pass filter to the FFT data, so that instead of getting wild fluctuations that might be happening really quickly between different windows of the FFT analysis, you get this kind of smoothing effect so that things move a little bit more gradually and aren't just kind of jumping around all over the place. And so that value can range between 0 and 1. If I give it a value of 1, it basically won't move. If I give it a value of 0, we'll see that it'll move a lot quicker than it's moving right now. So you can see it's much more quickly responsive when I don't have that smoothing value set. As soon as I go in and change the smoothing value, now things are maybe a little bit slower to respond. See, it takes a little bit of time between when I start talking and when the visuals actually come in, and when I stop talking, there's sort of this fade out that kind of happens inside of there. And having some ability to kind of control how responsive the visuals are to the FFT is really important, because otherwise you get really chaotic things that are just kind of flashing in and out all over the place, and you don't really have any ability to control that. And just in case it wasn't, just to make this arrow function thing super clear or more clear, I could also do this like this. So these two things are equivalent, or that function that I just put right here is equivalent to that arrow function that I had earlier, if that makes sense.
I understand the arrow function syntax. The problem is that, what do you do if you have several lines?
You have to explicitly include a return statement if you have several lines in an arrow function.
But like you separate the lines with a semicolon? Because like in JavaScript you have to do it.
No.
Yeah?
I promise you don't.
If you put the curly brackets and you have several lines, well, sometimes you don't, but like, for example, there in the face one, you have like a space separating the...
No, I mean, I could take all of these and stick them all up against each other, and it doesn't care.
No, I'm not talking about the chaining, but inside of the function. If you declare a variable inside of the function, and before the return, yeah, and then you just leave it like that and go to the next line. You don't have to put that semi.
I swear.
Okay. Okay, well.
But if you really want to read people argue with each other, go look up automatic semicolon insertion JavaScript, and you'll see people just wanting to rip each other's throats out for having disagreements about this. It's the dumbest thing you will ever read. But if you really want to read people fight about whether or not you have to use semicolons, yeah.
I use a linter at work, so we have a linter and I have to put this there.
Yeah.
Like I do get an
Yeah,
error,
yeah,
so
yeah.
this is why I'm like asking, because I use
Of course, if you
JavaScript.
use a linter, then yeah, you have to abide by the rules of the linter. But there's nothing in the language that says you have to have a semicolon, so that's just a linting rule. Yeah, that makes sense. But yeah, there's some really funny flame wars online about people arguing about whether or not semicolons should be mandatory, or it's kind of absurd. Any questions about how the FFT works inside of Hydra?
Can you console log the values of the FFT analysis, like see frequencies, just so I know what I'm mapping my things?
Yeah. Let's see, I could probably do console.log FFT, oops.
Alright.
So if you have
Something like that.
uh-huh.
Oh, that broke, no. Console, there we go.
Ah, okay, cool. And you can set as many as you wish. The
You can
bins.
have as many bands or bins, whatever you want to call it, as you want. Yeah. Well, I don't know about that. I don't know what happened if you. There must be some default size that's being used for the FFT analysis, and so you certainly can't go a higher number than whatever that bin.
So
I don't know. I don't know the details about how that works.
Performance bit, we knew we had lots of things, presumably.
So if you increase the number of bins, that means you have to increase the window size, so the performance hit would be the latency that you would have between different samples of the FFT. So it would be less responsive to the audio.
But how can I tweak the sensibility of this?
So you can do a couple of things, right? So you can change, you can use this set smooth function to kind of add like this low pass smoothing. You could also just explicitly go in, I mean right here I'm saying FFT times 10, but you could just change this value to some other thing. You could make your own logic to kind of average multiple frames of the FFT over time and just embed that function inside of there. I mean, I think the fact that you can just include your own function anywhere you want in the hydrograph it's something that's really cool and makes it really flexible in terms of what you're able to do with it. You can just kind of implement your own signal processing routines if you want and stick them in there.
Is there a way to reuse some part of that, sort of like to make a function, like an offset function, and pull kind of reuse it somewhere?
Like the graph kind of, you mean? Like
taking that bit of code there where you've got os or
Yeah.
dot out.
Yeah.
Is there any way you could have a library of functions that you've created that you could put in to reuse it?
Yeah, I mean, I think you could return like just this part of it or whatever from another function, and you can run Hydra inside of Atom, if you know that text editor.
Yeah.
So once you have that, you can just load any file that you want and have arbitrary functions inside of there. Yeah.